So the only reason there's some of them are kind of different is because your calculators are rounded kind of differently, but you should all have like 5.2 something, and then 9 point, but yeah, so it's all about the same. Okay, so what is that 5.21 and that 9.79, what does that mean? What are those values of? Okay, what is x? Height. Okay, so can you figure out everything else if you know what the height is? Okay, so, right, so we're going to use substitution. But also consider, do both of these height values that I found, do those work for the context of my problem? Was I allowed to have a height bigger than, like what happens when I had a height that was bigger than 6? Like what? When I had a height value that was exactly 6, what was my volume? Well, what's anything times 0? So, okay, come on. So think about, we were restricted from using certain numbers, okay? Y'all know how to, you know what to do? No. Yes, it would. No, I need you to get started a little bit faster on this. Yeah. Okay, so remember when I asked you, if you have the height value, do you have enough information to calculate the other dimensions? Yes, she is smart. Okay. She knows what she's doing. Talk to her. So you know that those are height values, and she knows how to find other values based off of the height. Okay?
What y'all got? What y'all
Have you talked? I don't even know if you're asking me what's right.
Ain't even a sports car.
For what? So is it possible to have a negative width? Okay, so let's see. Oh. Does 9.8 fit into the context? What was our restricted domain for this problem? Where are I getting 12 from? Okay, wait. Think about. Yeah. Okay. So. No. That was so remember, we're talking about those restricting the values of our height. Because remember, if we had a height of 0, or like you cut out to where the height was, 6, we'd have a width of 0. And what would that give us? If we had a width of 0, what would our volume be? Right. So thinking about like restrictions. In that sense, okay, so what was I restricted to? Only 6. Okay, so does 9 work? Okay, so see how when you tried to use that value of 9, it gave you a negative value for width? That ain't happening. So like, that's exactly why you have to consider the context of the problem. Okay. So KT, what, instead of using 9.8, what height value do you think you want to use? What's your other height value? Yeah! Okay.
This is for my width. What did you get from my
Okay. Yes. So when you did that times that, that's length times width. You're calculating the area. Look, you got that. You're using 5.2 for height, right? Okay. 5.2,
You say
right?
what for what?
And then length and width, remember, it's both of those. But when you multiply them together, that's when you're getting,
Together you get,
This would be your first time.
12. You just find 3 of it.
You get what for? You don't know.
You try 3 of them.
You have to get smart, sir.
let's do, oh, because it's minus, it's 2 times, the formula's 2 times the height. 2 times the height, make sure you get it. Yes, 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 yes. What's that? So, yeah. Okay, so yeah, if you're using that one for length, that would work out.
I be losing shit.
Well, so your height,
That's all I got on my.
okay, so,
That was fuck. Yeah, we're trying to get a little bit. I see his face.
so, yeah, if you simplify this, the length is gonna be more. And so you can also wanna have written down, like, when you calculate the volume, it'll be.
He's so cute. What do you get?
So we had 5.2, but you did it 8 times over. The equation is 8 times 2.
Alright, we'll
Tying up
I'm sure you can. I would with all the school.
Okay, so you have,
At least it's
analyze the graph. Okay, so what are those? Okay, so we've already talked about, what are we gonna do with those? Why?
Oh, no.
Tell her what they are. So that she knows how to use them and you know what they are. So y'all can work together to figure out the problem. Learn along the way, I hope. What's up? Okay, so why are we looking for the points of intersection?
Just so your body goes.
Possible, okay, we're looking for possible solutions. Okay, so, but those intersection values represent what, Caleb?
Oh, yeah, they did. Oh, you go.
You know the base area, you can 12 tells you that. You're trying to find everything else.
Like, so the area,
You're not really doing anything
2.5.
to try to get it.
It was 9.7.
I understand. It's okay, but, okay, so she said, you know these are height values. Well, Sheridan knows if I have a height, I can find out what the length is, I can find out what the width is. Yeah, I can figure out that too. How do I do that, Sheridan?
I don't do that. I just don't do that.
Yeah.
Are you
See what she's saying? Yeah, but just go ahead and round this to 2 decimal places.
So it multiplied 2 of those area.
2 decimal places, 5.21.
Yeah, like we have a C.
Okay. It's okay. Yeah, okay. Let's start, okay guys, let me get your attention up here, please. Alright, let's start talking about some of these ideas. So, when you graphed these 2 functions, we had 2 points of intersections, right? So that means, what does that mean? Say it. Okay, so we are going to be analyzing the x values of these two possible solutions. Okay, so what were those 2 points of intersection?
Let me tell you, 5.21, 9.7. Oh, way off.
And then 9.7.
9.
Okay, so guys, I want you to think about, on the graph, what did our x represent and what did the y represent?
It's height.
Okay, x is height, because remember, we're writing these things, or like our length and our width is all written in terms of the height. So, this is what I was talking about, think about in the context of our problem, what is our domain restricted to?
1 through 6.
Okay, so our domain's restricted to all the values between 0 and 6. We just want to be very clear about it can be everything just barely greater than 0, and then just like 5.99999 would work, right? But what happened if our height was 6? Right, because when we had that, we had certain values, and also remember graphically that's where it would cross the x-axis. Our x-intercepts were places where if we had this value of height, the volume would be 0. Okay, so context of the problem, which height values would work here? Okay, so a height value of 5.21 is that our domain, and I'll even point out group 5 over here, they used a height value of 9.79 to start calculating length and width, and then what happened in KT, what happened when you substituted 9.79 into the width formula? Okay, so he got a negative value. So can width be negative?
No.
Okay, so also if you didn't pay attention to the context of our problem and you went to calculate the dimensions and you get something negative, you know right away you probably did something wrong because we can't have a negative width. Does that make sense? Okay, so now going on from here, we know that our height is 5.21 inches. Tracy, tell me how you calculated length.
Oh, I did 18 minus 2 times 5.1.
Okay, and what did you get?
7.8.
Okay. Caleb, what'd you do to calculate width?
12 minus 2 times 5.2.
Okay, and what'd you get?
1.58. Ain't it supposed to be 7.58?
What's up, guys?
Is it 7.58?
Oh, 7.58. Oh, so we also talked about this in the other class. When we're talking about when we're rounding our decimals here, typically go ahead and round to 2 decimal places, but then when you get to the end and you're comparing your answers with your group, like if my answer was 7.58 and the person next to me had like 7.6 or 7 point something close, I'm not going to worry about it. Mr. Kenny's not going to worry about it. Like, it's just, the answers are slightly different depending on how you round it along the way, okay? But that doesn't change, like, the meaning of anything. So, with height, okay, lastly, so the volume of this planar box would be calculated how?
5.2 times 7.58 times 1.58.
Okay, so where are these numbers coming from, Caleb? Okay, so Caleb's getting volume by doing length times width times height. So what do you guys get when you do that?
71.6.
Okay, is this all I need to write to tell you what the volume is? What am I missing here? Okay, inches cubed, because our volume's a cubic function. Okay guys, so this idea of like using like information you're given to help you figure out other things and working backwards, okay, all these ideas, we're about to continue to apply them. Okay, go ahead and go to this page in your book, 3.2. Okay, so in 3.1, we were given this scenario of these planter boxes. They were making rectangular planter boxes. We're still dealing with the same company, but now they make cylindrical boxes, or not boxes, cylindrical planters too. So now we're gonna calculate. We're gonna see how volume. We're going to be exploring the ideas of volume for this now. So when it says the cylindrical planters come in a variety of sizes, but they all have a height that is twice the radius. Okay? Keep that in mind as you look at this table that's like right below. So this table is going to be, we're going to fill it in similarly to how we did that first table a few days ago. And it gives us the radius, okay? What did it tell us about the height? Okay, height is 2 times the radius. If I'm given a radius, can I figure out what the height is?
Yes.
What am I going to do? Okay, we're going to multiply by 2. Some people in the other class said that we would have to square it. Does twice something mean square it? No. Okay, so multiplying by 2, same thing as doubling it. Also, something that I forgot to tell the last class, so I'll go ahead and write that here, so since our radius is in terms of x, we're going to keep that consistent throughout our whole table. So our height was equal to what in terms of x? Like if I'm given a radius, which is my x, how do I find the height?
Times 2. Multiply by 2.
Okay? Okay, and then I want you to look at your paper. How can we figure out what the base area is with the information we're given? Like if you're looking at me, read. You're looking at your book. Base area. We're looking for base area. What's up? Yes, where is that coming from? Okay, y'all see that box? Y'all see that box in your book? It says base area equals. What does it equal?
I don't see it.
Oh, okay, sorry. It says area of a circle is what it says in that box. But okay, let's think about what is when it's talking about, I don't have the shape up here, but that cylinder up here on the top of your page, what is the base of the cylinder? Like what shape is that? Okay, so when we're calculating the base area, essentially we're calculating the area of a circle. So do y'all remember it being area circle pi squared? Does that ring any bells?
Yes, they do.
Okay, so, but instead of r, what are we using here to represent the radius? Okay, so also this is part of the, yes, keeping it consistent here. So I'll do base area equals. Okay, so you guys in your groups are going to work to fill out this table. This last row is the same as the last row in our other table in the sense that you're writing everything in terms of like your radius. So in here, everything's going to be in terms of x. And then one thing I want you guys to notice here that's different from our last table is this line right here where it gives you a volume. So I guess typically like our last table followed that pattern of 1, 2, 3, 4, 5. Don't assume the radius is 5 here because the fact that it gives you this volume, it wants you to work backwards to figure out what this radius is. Okay? So if you said this was 5, then your height's going to be 10. And when you calculate this, it was like 70 something. It doesn't work out. So like you'll see when you get there, you kind of have to find what that radius is, but it drops the pattern a little bit. And then when we start analyzing the table, we just don't consider this row. We're just going to analyze the pattern of like these. Okay, so go ahead and get started in your groups to work. Go ahead and try and fill out this whole table. Height, base area. Okay, it's you guys' job to figure out in your groups, how is volume calculated for a cylinder given this information? And then go ahead and start thinking about B and C, or just like follow-up questions to support this. Okay, so in your groups.
Squares.
I did. Oh, it's not competition.
Height is too much, that's what's it.
Yes, ma'am.
He thinks it's a competition.
So let's get to work on collaborating and helping each other grow and learn.
Yeah, but I'm just gonna, yes, that's exactly how you do it, but instead of orange, I'm
Talk
gonna
about
try
the
X.
grade.
Since all, since our, since it's saying the radius is like the X value, we're calculating like everything else. So I know it's not always saying X. That way it's not like, kind of the same thing, we don't know. Does that make sense? Okay, and so this one, you got your height on two. How do you alright? Yes, okay, so go ahead and write that in that box, and you can write it there.
Exactly. 4 brains are smarter than one.
What's up? What's what? So X is the radius, I guess you're out. X is our, so if our radius, it's the same thing as like how our height was the H, and then we use that to go with
So
everything.
like 2 might want to
4 times.
It says, hold on, look, it says height is twice the radius. So, if-
2 times?
yes. Okay, what's up? Okay, so you wanna do pi times x squared. You know what x is? Why not? Do I have height on this table? What? Oh, I do have height on this table. What's my x? But it tells you what x is at the bottom. What is x? Okay, so you see how that, okay, so how you're thinking about how height was like the only thing we talked about for the last table, for the rectangles? Radius is our new bestie. Pi times the x, and then, but you have to square the x. Yes.
Can you just put 3.14 or go over to the pi
Oh, just for the.
I don't know, so I'm trying to think about what the last class did. I just know like we rounded. Hey guys, in this base area column, round everything to 2 decimal places. And then when you're multiplying, is it easier to use the pi button or is it easier to use 3.14?
Cause 3.14, I mean, it's.
Use use the pi button to be more accurate, but then round it back. Yeah, use the pi button to be more accurate and then round this to 2 decimals because it'll help this be more accurate. You'll see what I mean. So I'm gonna write on here.
I don't. Might go somewhere else.
Okay.
No, sir.